Hello guys, a very good evening. We are uh, awaiting for a couple of more people, and welcome to day 13th in order to complete your array with all the known algorithms and known techniques to solve the problem related to arrays. Will be beginning in a couple of minutes. Let me know who joined. Hello sir, Aniket sir. And am I audible, guys? Am I audible? Am I audible? Loud, clear, everything is fine. Mic, audio, video, everything is working fine. So, let me know who all joined, guys, quickly. Yes, okay. Okay, so I don't know that how many guys are gonna join today. We'll begin the session from this instance only. A couple of guys joined, and so we are in day 13th of array series, and that we'll be covering Kadane's algorithm today, and one more question, longest consecutive sequence. So these two questions we'll be covering today. If time permits for the day, we'll cover one more maximum products sub-array question. These three questions I was planning to carry today in the session. Okay, so we'll start with the first thing. First of all, this is Kadane's algorithm. So to begin with, we'll be having a very good session today. Kadane's algorithm. So Kadane's algorithm is used to find maximum sub-array sum. Okay, so let's begin with a couple of examples. That particular question is lead code 53. Lead code 53. This question is of lead code 53. So given an array that is -2 1 -3 4 -1 2 1 -5 and 4. Okay, great guys, great. So this is the array given to us, and they are asking for maximum sum sub-array. Okay, I hope that we have covered a couple of questions like this in our past. So what could be the brute force, guys? Approach 1, that is brute force / approach 1. So brute force could be go for all the indices from I0 to n-1, again for J0 to J not 0, yes, J0 to not 0, Ji to n-1, and then for k is equals to I to j, right, something like this, and then what we can do is that sum plus equals to ARR of k, and if max sum, we will having one more variable as max sum, and max sum will be math.max of sum comma max sum, right. So this is the brute force for us. So this might be the brute force for us. We can find all the sub arrays, and then we can find the sum of it, and we can say whatever the sum they are getting. Like after this, we just, I made one mistake, guys. So after this, yes, so this bracket will close over here, this bracket will close over here, and something like this will happen. I'm not gonna write everything. So something like this will happen, okay, and we'll be able to find the solution in order of n cube time. Now comes the approach 2. We can use prefix array, prefix sum array to find out the maximum sum. It will take order of n square time. If you have not watched the prefix sum approach, you can go back and watch in this series only. That is pretty much straightforward to you. Then comes the best approach, approach 3, that is Kadane's algo. Now let's begin our magic. So do I need to do a dry run on this, guys? You guys need a dry run for this problem? Let me know if you need a dry run, guys. Quickly respond if you guys need the dry run, and keep responding, guys, so that I am able to know that okay, you are getting the solution or you are not getting the solution. First, let me know if you want me to dry run this problem. You want dry run? I'm waiting for your responses, guys. No. Like 5 people are there, at least 4 no's should be there, so that I will skip the dry run, or else I can do a dry run. That is, so let's do a dry run. Let's leave it everything. Okay. So they are just asking maximum sum sub array. The name itself is clear, guys. Okay. The name itself says that you need to find a sub array whose sum is maximum. That's it. So let's check whatever sum. So over here it is -2, over here it is 1, up to here the sum is 1, up to here the sum is, what is the sum now? So like you can calculate the sum, like it will be -2, 1, and again if it will be like 1 minus, then it will be -2 again, then it will be 6. So somewhat you will be getting the maximum sum over here only. Whatever I can see is this only, because over here it is -5. So the sum will come somewhere around 6. 4 plus 2 plus this 1, 7 minus 1, that is 6. So okay, Parth needs the dry run. Okay, guys. Okay, guys, I'll write a couple of more examples. Just hold on, guys. Okay, guys, so if you need a dry run, I'll maybe I can write the piece of code so that you can get the dry run. So this algo, this particular algorithm makes you sure that you are having the best sum till that point of time. Whatever the best sum you can have, they are having the best sum. So how this algo runs? This algo states that you are having the best sum as of now. We will be having two variables. The first variable is current sum, that is often represented as cur sum, which will be pointing to the first index of the array, and the other variable will be max sum. That can be what it can be, it can be it should also be pointing to the first index, like these will be maximum and current sum. So as per Parth, we'll do a very good dry run on this particular problem, and then we'll be moving forward to write the code for this. Okay, let's check if we have enough space. Yes, we should go to next page, and I'll be. So what I said is, we'll omit this. We'll be having first, this is current sum, that is initially pointing to -2. Then we'll be having maximum sum, that will be initially pointing to -2, and we will be on index as 0. Till so far so good, no problem. Okay guys, our aim is to find maximum sum subarray, maximum sum, whose the subarray with the sum having maximum in that particular range, in that particular area, in that particular array, whatever it is, we have to find it. It can be like only one element over here, that is also like that is also doable part. Okay, it can be like a couple of more element like this, like a sub array. That sub array can be like of length 3, 4, 5, it could be of anything. This algorithm will take care of it. So what we can do is, so okay guys, do you believe one thing, first thing, that in a scenario like this, I'll write a scenario, I'll write the scenario over here. In a scenario like this, just suppose given an array like this, -1, -5, 100, -6, -4, -2. So in this particular question, can you let me know what could be the maximum sum subarray? If I am not wrong guys, the maximum sum subarray in this particular example would be 100 only. Yes or no? Yes, because this is the one number can also be, one index can also be a subarray. It is also treated as subarray. If it is treated as subarray, then its sum can also be contributed to maximum sum, and over here it is the maximum sum, that 100 is the maximum. Else if you ever check, 105 is also giving some 95, 106 is giving 94, huh? Every time if you go left or right, it will only decrease, only the value of the maximum sum will decrease only. So first thing first, like let's not memorize the algo, let's intuitively build this algorithm. So at any instance that num of I, that num, so this over here we have array, so that array of I, that at any instance that array of I could also be the maximum sum regardless of current sum. Like let's have a look. The current sum over here is -1. If we go to this, the current sum would become -6, and again if we add this 100, the current sum would become 94. But up to here, is the maximum sum 94? No, because up to here, if we look at this particular index, this is all, this itself is giving you 100. Yes or no? Yes or no guys? It is giving you 100. So my dear friends, what we can do is, we can simply have a check that if, so what could be the current sum? So current sum could be just current sum could be, I am just writing something, let me know if it is making sense to you or not, that ARR of I, or I'll just move it little left, that current sum could be math.max of ARR of I, or whatever the current sum is plus ARR of I. Suppose if this one, we'll go with one more example, just hold on guys, we'll go with one more example. So we'll omit this, we'll go with one more example so that it's very much clear to you. Okay, if we have arrays like this, and suppose if the array was like this, 1, 5, 100, and then -6, -4 and minus 2. Okay, so the first time the current sum will be like 1, again if you move the current sum is like 6. If you go over there it is 96. How it is 96? Because we are adding current sum to now's element, whichever index we are having now, whichever index we are on now. So on now we are on index number 2. So we should add that index to current sum to check, okay, if this index is having the maximum sum or not. And to handle this case, we are just checking that, okay, if that particular element alone itself is giving you the maximum sum, or it may be possible if all these whatever the elements which are given in the array are negative, and if that element is positive itself in itself it is positive, then it could be like okay, we can also check with that particular array of element. Do you agree with this statement? Yes or no, guys? Do you agree with this statement? Is this statement making sense to you? So first of all, without this statement making sense, I won't move ahead today. So is this statement making sense to you guys? With these two examples, whatever we have like studied, don't memorize it, guys. Memorizing won't help, guys. If you understand this particular pattern, then it is fine. Like, this is the only crux of Kadane's algo, that's it. Like, I'll write the algorithm, we'll also write the code for the same. But is this statement making sense to you guys? Everyone, like 4 people are there in the chat. I at least need 3 responses, guys, to move forward. Okay, yes, every one of them replied. Okay, so sorry guys. So okay, so I'll quickly cut this and I'll quickly paste this so that I don't need to write it again. Okay, copy. So this is one statement made sense. Okay, this statement made sense to you guys. Okay, now maximum sum can be like whatever maximum sum it could be. Like, maximum sum can be like max. What is the maximum sum every time? Max sum can be math dot max of the current sum or previous whatever sum they have stored. Is this statement also making sense to you guys? This is nothing like rocket science. This particular portion is not rocket science. We have written it multiple times, and like it's the part of journey. So is both statement making sense to you guys? And we can go from for I is equals to 1 to I less than n I plus plus, because we have already declared our current sum and maximum sum as ARR of 0. So our current sum initially pointed to ARR of 0 and max sum also pointed to ARR of 0. So is this algo making sense to you guys? Let's move forward and code this quickly. Let's keep a habit of coding every algo so that you guys are not stuck anywhere in the so maximum sum sub array. Okay, is my screen visible to you guys? Let's code. So what two variables we were having? Int cur sum is equals to nums of 0 comma max sum equals to nums of 0, है ना? For int I equals to 0 से I less than n I plus plus, one thing to be taken care of, that int n is equals to, have a good habit of writing something like this. Int n is every time once you go forward, write this. So this itself, if I am like, if I am judging you, if I am the on the other side of the interview for your interview, if you are writing something like this will impress me that okay, this guy is writing clean code. So keep a habit of writing something like this every single time. Just learn, like I am also not perfect in everything, but something I am learning, and this is one of the best thing which I have learned. Like I'll teach you a couple of more things. Hold on. Like if I have to, okay, I'll teach you something. Okay, let's write it some in some other way. Okay, let's write with this with while loop. Okay, you can write this with that too. While index is less than n, right? I'll teach you one of the best tricks I have learned. So cur sum is equals to math dot max of what, that nums of I let's write okay, learn here, learn something like this here. Over here I'll teach you a couple of good things now today. So int num is equals to, what will be number over here? Number will be nums of I index, and that too plus plus. I'll teach you what I did. So num itself, that is index, and what else, cur sum plus num, and max sum is equals to math dot max of cur sum comma max sum. That's it, end of the story, guys. Return max sum. Done. Let's see, hope. So it is saying, what it is saying, cur sum. Okay, so cur sum is CURR, right? Any more solutions? Okay, let's submit. That's it, as simple as that. So what I did over here is, I didn't wrote index plus plus as a new line, I wrote it in this only. Simple. I have, like, these kind of tricks impresses the interviewer in front of you, that okay, this guy is in practice of writing good and clean code. So these kind of approaches make sure that you are having something like this. Let's move forward to the next question, guys. Our next question. So do let me know if you have any doubts in this question, guys. Do let me know. So this question was one of the easiest question to respond to. So do let me know if this Kadane's algo is making sense to you. Guys, come on, more responses, guys. Come on, quickly, more responses, guys. More responses, guys. More responses, boys. Are you having any doubts in it? No. Clear? Come on, quicker guys, quicker, very quicker, so that we can move forward to next question. I also need to do something for me today. So our next question goes like I hope this is clear to every one of you, and you can also solve maximum sub array which is there in the class sheet, and that is marked as question number 53. I'm marking it as done. So wait, so this is what we have prepared. If it is taught, it is like done. If it is not taught, it is not done. Okay, so something like this is already prepared. So this question is not done in our class. We will try to cover this question. Meanwhile, you try this question, corporate flight booking. I see that like we'll discuss this later, not discuss on the, yes, okay. So we'll go to our next question of the day, that is longest consecutive sequence. Okay guys, so this is one of the best question of approach named by me itself. Nobody named it again. इसका वास्तविकता से कोई संबंध नहीं है, इसको मैंने खुद के लिए नाम देके रखा है, इसको मैंने अपने नेम से रखा है फाइंड मीन अप्रोच. So what helps you to what helps you in naming such kind of thing? So like if you name sometime na, if you name something like this na, you will be able to remember that okay, you have certain algorithms. You will write all the algo on a single sheet of paper, because nobody is gonna remember everything every single time at every instance. You'll write everything sequentially and you will keep on revising daily on daily basis. So if you are revising those stuffs on daily basis, a day will come once you will be able to recollect every single thing within 15 minutes for array topics, and that day you will be prepared for interview. I'm sorry, we'll go to our question. The question goes like this. The question is lead code 128 and this says longest consecutive sequence. Okay. So longest consecutive sequence goes like this. If you are given an array says like you have 100, then you have 1, then you have 2, then you have 3, then you have 101, 102, 103, 104, and then you have 5, 6, 7. So I just wrote a imaginary example जिसका वास्तविकता से कोई संबंध नहीं है. So they are asking, you are given an unsorted array. The array is unsorted. First point. Second point, you need to return longest consecutive sequence. Consecutive sequence means 1, 2, 3. Suppose we can write one more 4 over here. I'm not like good with writing examples. So 1, 2, 3, 4, 5, 6, 7. So this is like 4 here and 3 here. 7 longest consecutive sequence over here. 1, 2, 3, 4 and 4 over here. Total 4 and 7. So we should return the answer as 7. The longest consecutive sequence is 1, 2, 3, 4, 5, 6, 7. So let me know what time you will take to solve this question. Like what, not time, I am asking what complexity you will take to solve this question. The naive approach, let me know the naive approach. I will wait for a couple of minutes for you to come up with a solution, and I want like whosoever is there in the chat today, if like learn one thing. If you are consistent daily, trust me, whatever I have learnt from 4 to 5 years, I'll teach you in 6 to 7 months. So barely if you are consistent daily, because I see like a lot of guys and girls are not consistent. No problem, if they are not consistent, it's their loss, not my loss. I am revising daily with like n number of problems. I am revising daily, and if on a certain point of time, if the guys are not interested, I'll close this up too. No problem. I'm not doing this for views or some kind of I have some kind of thoughts as of now, but try to be consistent. If you are consistent enough, if I am getting like 5 to 6 persons daily watching the stream, that's fine. I'll carry on until DP. I'll teach you DP. But if you are like, if everyone is inconsistent, then I myself won't get motivated to teach, right? So this is one of the thing. Which gap are you asking, Aniket? Okay guys, let me know. Yes. So the gap in between this array doesn't matters. So it is just asking, so what is the maximum length you can find in this array? What is the maximum length of consecutive subsequence? Longest consecutive subsequence you can find. You just need to return answer 7. You don't need to return the completely sequence. You don't need to return the sequence. You just need to return, okay, 7 is found. My doubt is 1 2 1 not 2 1 not 3, then we will consider the 7 length array. No, it's not like that. You got the question, right? So like you need to find what is the maximum consecutive sequence present in the array. Like it is the array could like be this only, this two, right? I just wrote up for example, the array could be like this one also: 4 2 3 1 100 5 101 102 6 103 7. So this is the answer for this, and this is same only 7. Something goes like 1 2 3 4 5 6 and 7. So both the arrays are same only. They asked that the arrays are unsorted. N log n. Okay. So Paras came with a logic saying that he can solve that particular problem in n log n time. Very good. So basically Paras will sort the array and then he will yes, very good. This is the naive approach you can take. Very good. But what, like guys, a couple of more responses. If you sort the array, if you can sort the array and if you can solve this problem, then I might not be teaching this problem, right? There is something great in it. With sorting, yes, with sorting we can do this in n log n time. Fine, I agree with this statement. Guys, whosoever is watching, Samkit is not there in the chat today. Samkit, are you there? Any more responses, guys? No responses? No problem. We'll move forward with the next approach. So okay. So suppose guys, just suppose if somehow we are able to see, that if somehow we are able to see or find minimum of starting sequence, like over here in this sequence the minimum is 1 and over here the minimum is 100. So the minimum is 1, then minimum goes like 2, then goes like 3, then goes like 4, then goes like 5, and then it will go to 6, and then it will go to 7. And over here from 100 to 101, 102 and 103. So this is how it is going. Okay guys, great. If somehow we are able to find minimum, then if we can store this in hash set, okay. So suppose we iterate over the array and we store everything into the hash set. I am not drawing the hash set now. So everything is into hash set. So if we somehow wrote a magical function which gives the minimum of every sequence, minimum of every sequence, minimum of so this is what we thought of. Okay, then if we got minimum, then we can say okay, we can check if minimum the number plus 1 exists. Yes, if it is plus 1 exists, so that is 2 exists. Yes, increase the length by 1, length plus plus. Then again if you can check 3 exists, again increase the length plus 1. Then if you can say 4 exists in the set, then we can say okay, length plus plus. Then we can check 5 exists, again we will say length plus plus. If we say 6 exists, then we will say length plus plus. If we say 7 exists, then we will say length plus plus. Ultimately we will get the length as 7 for this subsequence. Yes or no? Subsequence length is 7. And again if you got this 100 as minimum, so we will say okay, 100 exists, length equals to 1. 101 exists, length equals to 2. 102 exists, length equals to 3. 103 exists, length is equals to 4. Great. So we are able to find the length, and if we can store that length into max length and we can calculate that particular value, will we be able to find this? Yes or no, guys? Will, if somehow we find minimum of every subsequence, every sequence, and we'll do this simple approach, simple technique. First of all, do let me know, just forget this. Are you able to get this with this dry run, with this simple dry run, or do you want me to write code and do the dry run for the same? You got this dry run, guys, this messy dry run. Are you able to get the messy dry run, or you want me to spoon feed you? Like honest responses, guys, honest. Like I can do spoon feed too, no problem. If you are not getting it, I can write everything and make you get it, because you are looking this problem for the first time and I am looking for it like second or third time. So that's easy for me, that's look easy to me, but it's not, it might not be easy to you. I'm not taking you as of my like my intelligence or like my experience on this problem, not intelligence, because you guys are much more intelligent than me. So this dry run is making sense to you guys? Am I making sense? Is this dry run making sense to you guys? Come on guys, respond. Only 2 response out of 5. I need at least 2 more to go ahead. Guys, 2 more responses guys. Yes or no you can write ना, मतलब नहीं समझ में आया तो बताओ तो सही नहीं समझ में आ रहा कि हाँ, अगर तुमको मिनिमम मिल गया तो मिनिमम से वाइल लूप लगा कर +1 चेक करते रहोगे, हैश सेट में अगर एग्जिस्ट करता है तो लेंथ बढ़ाते रहो और मैक्स लेंथ को अपडेट करते रहोगे, तुम अपडेट कर सकते हो. तो दैट्स इट. सेम लाइक दिस, सेम लाइक दिस, जस्ट सेम लाइक दिस, जस्ट सेम लाइक दिस. डू एवरीथिंग, कीप ऑन चेकिंग इन हैश सेट. ओवर हियर हम लोग यहाँ पे चेक कर रहे हो, वहाँ पे हैश सेट में चेक कर सकते हैं. बस ये बताओ तुमको समझा कि नहीं. हाँ, we'll go to magical function. We can go to magical function. Yes. So 1, 2, 3, 4 responses are great. Okay. I don't know who is the 5th person. भाई वो रिस्पॉन्ड ही नहीं कर रहा है, पूरे मैच में उसने रिस्पॉन्ड ही नहीं किया है. ओके, सो लेट्स गो टू मैजिकल फंक्शन. मैजिकल फंक्शन देख के तुम लोग हंस मत देना, ठीक है. मैजिकल फंक्शन देख के डू नॉट लाफ एट इट. ओके. मैजिकल फंक्शन सेज कि इफ उसका एक मतलब इफ वी आर एट एरे ऑफ इंडेक्स आई दैट इज 5, सो वील जस्ट चेक इन द हैश सेट इफ 5 - 1 4 एग्जिस्ट इन द हैश सेट और नॉट. दिस इज द मैजिकल फंक्शन. जस्ट वील चेक 5 - 1 exists in the hash set or not. If it exists, then it is not the minimum of the subsequence, because we have stored everything in the hash set first. Like I'll write guys. इतना आसान था मैजिकल फंक्शन, बस मैंने हवा बना दिया था. So we'll check every time if hash set contains जो num आएगा इंडेक्स पे, num -1 if that contains num minus 1, it means that it is somewhat between it is like 4 3 2 1. So it says if you go on this, so like we have already passed through all the arrays, we have already passed all the arrays in the hash set. So if you go, we will check, okay, 4 minus 1, 3 exists. It means that it is not the minimum. We need to get the minimum. We still need to get the minimum. We can go to 3. We can go to 3 and we will check, okay, 3 minus 1, 2 exists. It is not. 3 will say, no, I am not the minimum. Check for the minimum. It will go to 2. 2 will say 2 minus 1 exists, yes. So it will say, no, I am not the minimum. Go get for the minimum. Again, if you go to 1, so 1 will say, no, I am not the minimum. Okay, 1, no, 1 won't say this, because 1 minus 1 will say 0, and 0 doesn't exist in the hash set. So if this doesn't exist in the set, so it will say, okay, I am the minimum. Start traversing from me and look whatever the longest subsequence you can find. Same goes for 100. So if you go to 100 and check, okay, 100 minus 1, 99 doesn't exist. So 100 will say, okay, I am the minimum. Start traversing from me and look whatever the maximum length you can get from here. So if you are able to find the minimum anyhow, if you are able to find the minimum, your task is done, guys. It's as simple as that. If you are able to find the minimum, from there you can just proceed ahead and check, okay, what if, till what point of time you are able to get that particular solution, till what point of time you are able to get the maximum length. Okay, so is this magical function clear to you guys? If you are at 4, you will say 4 minus 1, it is 3. 4 minus 1, it will say 3. 3 exists in the hash set. So it will say, no, 4 is not the minimum, because 3 still is existing in the hash set. 3 can be minimum, go to 3. Like, don't go to 3, go to the next number. Go to the next number of the array. Like after 4, it could be 102. So if you go to 100, it will say, okay, 100 minus 1, 99 doesn't exist in the array. It means doesn't exist in the set. That means our task is to find the minimum of every subsequence. Once you find the minimum of every subsequence, every sequence, you can start moving forward from there until whatever time you are getting the length. That is your maximum length, right? As pretty much simple, as straightforward as it can be. So guys, do let me know if this magical function and if this problem is making sense to you. I want every 4 of you to respond. Like whosoever there in the chat, kindly respond, guys. Kindly respond. So let's write the code for the same. Okay guys, so let's go and write the code for the same. Let's keep a good habit of writing code every time. Okay guys, let's begin the coding. So as usual, we'll write int n is equals to nums.length then we'll be having a hash set to store everything, right? We'll be having this hash set to store everything. The hash set will be of type integer and we'll say, okay, set is equals to new hash set. Okay, now we can go to for loop. Int I equals to 0, I less than n, I plus plus. Okay, we'll say set dot add nums of I. Up to here, so far so good. We'll go to next iteration. Now what is our task? Our task is to find the minimum. Once we find the minimum, we'll do something. Okay, so our task is to find the minimum. if you find the minimum. So we can name this approach as find mean approach. Okay, but like these kind of small techniques will help you to apply these kind of techniques. You can apply these kind of techniques in some kind of hard problem to solve it up to some extent. So once you are able to solve it up to some extent, you will be able to find, okay, something else is there, something else is there. Like couple of medium problems are combined together and it will form a hard problem. Okay, couple of easy problems are combined together and it will form a medium problem. Okay, so something like this. So what we need to do, we need to find the minimum. So what we can do, for again we will go to int I equals to 0, I less than n, I plus plus. Okay, okay, so we'll write a helper function. I can also write over here only, but I just want to make a clean code for you guys. Okay, so if, let's say, if set dot contains nums of I minus 1, if it contains nums of I minus 1, that means it is the minimum. But if it is not the minimum, but if it does not contains I minus 1, it means, like, if it, for our case it was 1, so 1 minus 1, 0 was not there in the set, 0 was not there in the array. So if it does not contains 0, it means that that number, if that for 100 it was 99, so 99 was not there in the array, it means that that number is the minimum number, the 100 is the minimum. So we can say find max. So we can say over here max length. So max length is equals to 0. So we can say max length is equals to math dot max of max length comma find sequence, है ना, find sequence, and we will be passing this hash set. The hash set will go like this, set and comma number will be nums of I. That's it. So this will return the length from, so what this sequence, what this find sequence will do, this sequence, this method will return the length which is possible from that particular number. Like if we are giving this if we are giving 100 input to this particular find sequence, so it will be returning 4 as per our example, right? Because 100, 101, 102, 103, so these were the 4 numbers now. So it will return 4, and in which case, in if you are giving us, if we are giving 1 to this find sequence, it will return 7. So we are checking every time, okay, whichever is the max length, we'll be just returning max length from here. That's it. Okay, no problem. So far so good. We'll just go and implement this function. So what this function will take? This function will take a hash set of what type? It will take a hash set of integer type, guys. Integer type, we'll name this as set, and we'll get the int num, which is the minimum. Okay, so we'll say int length is equals to 0. Okay, while we can also say while num set dot contains num. So we'll say num plus plus len plus plus, and at the end of the day we'll return len. That's it, guys. So we are returning length and we are returning this max length. Let's see what syntactical mistakes we have done. So it says that nums cannot be found. Where is nums? Okay, sorry, by mistake I have written num. It says what it is saying, max length, what it says, class solution cannot find the symbol max length, length. Acha, okay, sorry guys, sorry. So there is a ambiguity in the spelling of max length. So far it looks good. and this is how it says TLE guys, TLE, 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 TLE. Come on boys. Okay. So while set dot, so there is something fishy over here. Which case it is, which case it is TLE? Oh my god. Let's see. Why it is TLE boys? Why it is TLE? Have we done some kind of mistakes? Let's check. This is what we don't want, right? I0 to n, I plus plus, we have added set, we have added nums of I into set, right? And if we go from I0 to n and I plus plus, yes, and if we say if set does not contains max length, then we can find the max length nums ऑफ आई माइनस वन, अगर नहीं रहता है तो ही वो मैक्स लेंथ पे लेके आओ और फिर मैक्स लेंथ को रिटर्न कर दो, ठीक है. Fine enough, fair enough. Why it is giving TLE boys? Oh fuck, sorry guys, sorry, no, it's fine only, right? Set find sequence will return an int, and then int can be for first time it if it goes, so in some case it is not breaking, that is why it is giving us TLE. In some cases it is not breaking somewhere. If it contains num, it will go num plus plus length plus plus, num will increase by 1, length will increase by 1. Yes, sorry boys, just hold on, I'm analyzing what mistake I have done. Int len is equals to 0, यार len 0 होगा, पहली बार गया 5 था, चलो 1 था ना मेरा, तो नम 1 तो मिलेगा उसको, बोलेगा नम बढ़ा कर दिया 2 और लेंथ भी बढ़ा कर दिया 1, है ना, तो लेंथ 1 और नम 2 हो गया ना, तो वो जाके चेक करेगा नम दोबारा है क्या, तो नम दोबारा है तो उसमें वो जाएगा और फिर वो लेंथ बढ़ा करेगा, फिर वो जाएगा, फिर तो TLE क्यों दे रहा है ये? वाई इट इज गिविंग अस TLE बॉयज? भाई मैं ही नहीं पढ़ रहा हूँ, तुम भी पढ़ रहे हो, बताओ क्या TLE दे रहा है इधर? मैक्स लेंथ लिया, मैं डॉट मैक्स में सेट पास किया और नम्स ऑफ आई माइनस वन एग्जिस्ट नहीं करता है, तो इसका मतलब नम्स ऑफ आई रहेगा ना, मिनिमम रहेगा, हाँ मिनिमम वही रहेगा. फिर TLE किस बात का TLE है भाई? दोबारा सबमिट करो क्या? आई कुड हैव रन इट विदाउट सबमिटिंग इट, दैट कुड हैव गिवन मी द आंसर. Only 3 cases are not passing. I don't know why it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, something like this. Okay. Okay. My god. Let's check. Let's check, guys. Let's go to something called Chat GPT. Let's go. Like it is saying it's correct only, right? Okay. Oh, got it, guys, got it. So what we can do? What we can do is, got it, guys, got it. I'm sorry, guys. I'm sorry, boys. I'm sorry. I'm really sorry. So ये बोल रहा है कि मान लो मेरा जो स्टार्टिंग नंबर, जैसे मेरा यहाँ पे स्टार्टिंग नंबर इज सब, सो व्हाट दिस इज सेइंग इज, so suppose if we have starting number like 1 multiple times, okay, so we have 10 ones, okay, so if we have 10 ones now, this problem will fail, this solution will fail, because it will start, it will find, it will say that okay 1 is the minimum, and it will again start all the iteration, it will do everything for find sequence, and the answer will be same only, okay. If 1 is repeated for multiple times, I just didn't get the question clearly. The question is nowhere stating that we are not having duplicate numbers, they can also have duplicate numbers, so that is where I failed, and this is what interviewer will check. So we'll also create a number which will say minimum, which will say new hash set. So we'll keep storing so that we are not getting through duplicate hash sets, okay. And not min dot contains what, nums of I, and what we'll be doing is we'll be putting that min dot add nums of I, okay. Boys, we are done, and I hope this should not fail now. Yes, it is not failing, but yet it is coming with a very bad time complexity. Let's see how we can optimize it, if we can optimize it or not, because I don't feel that this question can be further optimized. So are you able to get that particular approach, guys? What it said, that for like there can be n number of minimums, right, and one number can be duplicated too. So for every number it is like recalculating everything instead of storing. So this is what the concept of dynamic programming is. If you have already calculated for a given number, you don't need to do it for other numbers like same number, or if you have already calculated the sum of the something which is giving you, say like if you are already calculated the sub sum like sub array, so you don't need to calculate for every array. like अगर तुमने उसके बच्चे का सब कुछ निकाल लिया है ना, तो पापा उसका ऑटोमेटिक निकाल देंगे, समझ रहे हो, ये बस इतना ही उसका कॉन्सेप्ट है कि अगर बेटा का तुमने सारा कैलकुलेशंस कर रखे हैं तो पापा ऑलरेडी निकल जाएंगे, ये कॉन्सेप्ट है डायनेमिक प्रोग्रामिंग का। देखते हैं क्या ऑप्टिमाइज कर पाएंगे हम लोग। तुम लोग क्वेश्चन समझ गए ना गाइस? लेट मी नो इफ यू गॉट द क्वेश्चन गाइस। So this is saying okay, let's check now what they have written. First set dot contains, okay, current num is equals to number, length is equals to, while set dot contains max length. Oh, so they are not considering that case, the case which I forget na, so they are not considering. So this is not the correct example. If you copy paste this solution to chat at the lead code, it won't pass. Okay, so that's it for today guys. Thank you everyone whosoever was there. So let me know first if the question, both the questions are clear to you. I think today's class was much easier. Just do one thing, that after this class just solve these two questions immediately. Just go and solve this question, finish this up, wrap this up for the day. That's it. So I'll be closing the session for the day. A very good night. We'll see you day after tomorrow, Saturday, mostly in the morning time. I'll try to teach a couple of hard problems where it will take more than 2 hours of the class. So be ready, be mentally ready, and if you can I am telling you, if you can revise merge sort algorithm on your own, that will be very great help to me. Okay, so revise merge sort algorithm before Saturday class. Try to implement merge sort algorithm with whatever way you can, and let's see you on tomorrow, not day after tomorrow. And till then, very goodbye, and take a good care of yourself. Keep studying lead code and keep solving DSA problems.